to
So
leave that and switch over to
we're live now.
okay.
All right. So let's see. That was a good start. It's a little. It does get a little bit complicated. Um,
Yeah, I just need two more monitors.
no, I do everything with two monitors. Fine. Oh, three monitors, one extra computer on the side, but I'm not doing anything on the extra computer.
Yeah, you need one for your microscope and you need one for your
Yeah. Um, okay. So
so I should be back to my regular account to view that.
um, to view your
The live stream to see what the other chat is.
yeah, you could go to your regular or your live stream page, and it'll be there.
Okay.
Okay, let's see. I'll pop this out. Hey, Dominic, how's it going? All right, and now I can share that. I think. All right, there you go. All right, we're all up and running. So go ahead. And
Oh, okay. Do we need to send out a tweet?
yeah, I can do that if you wanna.
Sure.
Let's see.
And see if we give a few seconds for people to come in here. While we're waiting, I'm still trying to get there.
So let's see. No, you don't need a new production computer. You could do it all on your same computer. So what you would need to do, Snork, so you've got your main scene, and you'd have your second transition scene. So that second transition scene, you would just instead of showing the RingCentral in the meeting or RingCentral on the screen in the middle, you would just switch to what you want to show. And then when you're ready to show everyone again, you would just go ahead and switch it back to your main scene in OBS. Now, it can confuse some people because when you're showing stuff, the only way they would have to see it is on the YouTube stream. They won't be able to see it in RingCentral. Uh,
Okay.
but it's one of the things you have to do it. I mean, even when if you're going to use Zoom, you're going to have to do it because when you share your screen as the host, it messes up things in RingCentral. So you won't be able, people won't be able to see the live chat, and also it could mess up other things as well. So
Well, we got somebody new, Dark Electrohead. We're
yeah,
just
he's
getting
been around.
started. We just sent out the tweet that everything is going on. In just a few minutes, we should be getting started here. Aban, did you get hit with huge rain?
It wasn't really that much.
There was all kinds of alerts about Boston getting soaked.
Uh, yeah,
Well,
it wasn't bad.
and Shirley's saying it was freezing in Philly, so I thought, okay, huge drop in temperature, huge drop in rain.
Yeah.
Okay. Um, well, I guess we could go ahead and start. How long before people usually pop in after you tweet?
Um, Not very long, but they might have expected us to start like 45 minutes ago, so maybe they might have fallen asleep.
Yeah, that could be.
Um,
Oh, well, there's always rewind, right?
yeah.
Okay, so let's see here. I can resize without bothering anything now. So, how can I get where I can see the normal screen? I'm only seeing you up there.
What do you mean, just me?
When on the RingCentral, I'm not seeing both of us up there. Usually I see
Um,
myself too. If we're talking, I see two people up.
okay.
Oh, I see it on the YouTube, but
Yeah.
all right. I was trying to have something where I could tell where my monitor's looking. Well, I mean, the screen, because I can't tell where I'm holding anything up if I can't see my own camera. So right now, I should be showing a little yellow thing on there. Is that visible?
Yes. It's a little blurry. Maybe if you put like a uniform black background behind it.
Yeah, I don't have. It's probably the camera's pointing down, so I don't think I have anything black up on it.
Okay.
Now, is it more visible with a little light
It's still blurry, but it's
coming to shape now?
it's still a little bit blurry. Try going off to the side where it's the background's. Oh, there you go. It's good.
Okay, this is a little 3D print, and at this range, it should look shiny in some places, and there are some little strings. I don't know if you can see them. This was created by what's called a filament deposition, where a line of plastic is fed into it, and as the plastic goes through a little nozzle, it is heated up. And as it heats up, it melts. And then all of the little places melt together. And of course, before we started, I was holding a nozzle. Which is now probably fallen off and ran across the room. So here we go. A piece of plastic, a little string of plastic, that's 1 kilogram of it here, is fed into a little nozzle that gets heated to about 300 degrees Fahrenheit, and it melts, and little printer behind me here, those little nozzle here, and it positions it on this, which moves back and forth, and the plastic moves across, depositing it in a controlled manner, one little dot at a time. Of course, it has to be a really tiny little thing. Going to switch over and show a screen capture. Okay, you should be seeing a gray screen right now. Is that right?
Yep.
Yvonne, you seeing a gray screen?
Yes. Sorry, I was muted.
And then with this gray screen, which is actually a microscope, the same device that I just had just shown up there. Now, this is what it actually looks like when you look at it close up. So,
1,000 times magnification, right?
Right. So you could see how it turned the string that was 1.75 millimeters in diameter, or 1,750 microns, into 20 or 200 micron strings. And that since they're all kind of hot, they all just kind of melted in together. And they melt into the form what I was trying to make. And 3D prints aren't as perfect as some people like to say they are. They're close. But as you get in and look closer, you see a little piece of string where the plastic is warm. It stretches out and you get these little strings across a hole. And the hole that looks so perfect is not perfect. You drill a hole with a drill and they don't look that good underneath the microscope either. So to the naked eye, they could look pretty good. But anyway, so you can see that there can be problems in it, in these little fan blades here, sample fan blades, at looking at them this close. You can see, and this was one I was playing with to see what pressures and what speeds I needed to move to do these fills. You can actually see where they did not, weren't spaced close enough and didn't have the material flowing at the right rate to completely fill out that fan. So what happens is prints layer by layer and puts down the plastic in the positions where it should melt together. And that's how it makes a 3D print. There are other methods of 3D printing. One starts with a goo that is UV sensitive, or ultraviolet light. And an ultraviolet light laser hits it. And where it hits it on the surface turns it into a hardened plastic. And it basically just keeps going, sinking. Your model sinks into the goo, and a new layer of glue flows over. The light comes back, and it makes another layer. Another method is to take a powder and fire a laser at the powder, and on each layer, draw what that layer should be. So you melt the plastic or even the metal into the layer it's supposed to be. So your 3D print is actually a whole bunch of slices that are on top of each other. And the program that turns your shape into the individual slices is actually called the slicer. So one of the material problems with 3D printing shows up right away in this close view, and that's getting the pieces of the filament to adhere to each other. If this had been something that had been molded, like an injection molded under high pressure, those parts would take that shape and fill quite well. So a really good 3D mold, although you can't do everything as a 3D mold, actually does a better job of consistent material properties. And that's one of the biggest problems with 3D printing, regardless of the material you use. And a best example is a katana sword. They're made by folding metal, heating it up, beating it with a hammer, and then folding it again, beating it with a hammer, folding again, beating it with a hammer, each time heating it up, and basically keep welding the folds back into each other. This gives a strength of materials by these really thin bands of metal that's been stretched and deformed. It's got tension in it. And the 3D printer prints what are called annealed materials. They don't store force in them. At least this type does not store force in them. So you'll never be able to 3D print a katana sword, because you will not have the stress built into the layers, or at least not of any of the current technologies we have for 3D. Now, 100 years from now, they might be laughing at us with whatever new technologies they have. But currently, everything we make with 3D printing is annealed. That means that a lot of people have the idea that now that we have 3D printers, we don't need factories. Well, a lot of the reason you need factories is a screw and a nut are not annealed. They're usually made with certain metal products. They have strength. You do not want a nut to have an unknown capability of having strength. So nuts and bolts for your car, for one thing, you will never be 3D printing. For your windshield, As you can see here, as we get down into the microscopic part, there's ripple. Ripple in a windshield would mean fuzziness. And as you look at each of the 3D printing properties, you have to say, what can I tolerate? Well, sometimes brackets, anything cosmetic, usually can be 3D printed. I'm not saying always. I'm not saying that there aren't situations where you can't. But and then in the case of this where it had materials that are suspended in air, sometimes two materials are 3D printed at the same time, and then one is eroded away by, you can use a water soluble or an alcohol soluble plastic, and it dissolves away, and you have a much better surface than the one I created here, and a lot less warping. As you can tell, when you get really in there, you just see blobs here and there. Yeah, that's because this was a trial where I wanted to set the machine up to extremely high performance, which means you've got to make a bunch of tests and see how do I have to tune the machine to get there. So this is an early reject, but early rejects are really good for showing problems. Other things that can be done, you can change the type of plastic. This will have ripples on it. This is a, of course I drop it. This is another 3D printed object, and just barely see, set the magnification here. That's too good. On this one, this is a container, not a sealed container, but it's basically a nest to put my Echo Dot in. And it has layers of plastic strings going one way that are fused with plastic strings going the other, as kind of as a net, but a very close net. And you can barely see that underneath it, you can see the other rows going the other way. Now, if you want to waste material, you could make this solid. I was trying to print it fast, and also if you skip areas, you can save time and have this didn't need to be strong. This didn't need to be able to hold water. So in this case, this was fine.
Hi.
So the rate of fill in 3D printing is also something controlled. Now, on a 3D printer, when it actually comes out, the strand size is always going to be solid. But you can create voids by spacing how far the strands are apart. When you're injection molding a part, the way a factory would make the parts that you're used to buying, sometimes you can inject into it foaming. That's just not possible in 3D printing yet. Materials you can 3D print so far, not only plastic, glass, clay, which can then be fired, which gives a pretty good object. Cakes and breads. People are starting to 3D print cakes and breads and cookies.
I have a question, Snork. Now, when we're talking about you can't make a katana sword, because of course plastic is going to be a different material. You can't, even if you folded it, it wouldn't be the same. Now, what about like a bow for a bow and arrow? I mean,
again, you have to play with materials a little bit. it's never going to be as good as a fiberglass bow.
Yep.
So if you know the weaknesses, you get around them, which means it's going to be a lot bigger and bulkier. You're probably, if you wanted to 3D print a bow, it's probably going to be a compound bow.
Yep.
And probably the ugliest looking compound bow you ever saw, except for one made out of PVC pipe.
Yeah.
But I don't see it as as a non-issue. And again, some of these other materials can be pretty hard. A fired clay actually is really good in compression. You can put a lot of force squeezing something. So the next thing is 3D prints don't have to be the product. As you can print a shape that you can turn into a mold, which is the actual best use for them. The first best use is just be able to hold something in your hand and say, yes, this is what I want it to look like, or this is about the size it's going to be. And there are some things that you just can't make with any other method, but you have to realize where the flaws are. And one of the best uses for 3D printing is 3D printing with wax and doing what's called lost wax molding, which is one of the oldest precision molding techniques on the planet. Rings tend to be made with lost wax molding. Intricate ornaments tend to be made with lost wax, where really good details are put into the wax. And then another type of material is poured over the wax, like plaster of Paris, or some type of material that'll withstand steel being poured into it. So gold from rings tends to do well being poured into plaster. So the 3D print can print what's really tough to make. And then the wax is melted out, leaving a hollow mold that you pour your metal into. And that's probably the best way to make actual metal with 3D mold. But again, it will be an annealed mold. It will not have strength like the metal of a formed, worked object like a katana sword or a gun barrel. You might be able to make a gun out of 3D plastic that is going to fire once. You can actually 3D print all the parts you need to be made as a mold to make the gun.
Makes sense.
But the my hands, okay. For some reason, it knows my fingers. Once it sees my fingers, it'll focus.
You're still on the share screen, so we can.
Oh! I'm looking over. Yeah, sorry about that. And then setting up of 3D print, you put it into another device. This is the next thing up on the line here. I'm getting ready to actually tell it to make one. And in this case, this little. Am I in the shared screen? Do you see something yellow up on the screen? It's like a white screen, blue, and a little checkerboard in the middle.
No.
Did I stop sharing?
Yeah.
In this case, you see it now. Should be basically a white screen that has a little checkerboard toward the bottom and then a yellow thing in the middle.
Yes. Sorry, I was muted.
Okay. So this, I can tell it how high each of the layers are, how long I want the lines to be, what width they're going to be, what temperatures different parts of the mold are made at, how much is getting filled in between the lines, speed that it's zipping around on the machine at, and I can rotate the part. And you can see as I rotate the part, it takes different times to print depending on the orientation. So it takes an extra hour for me to flip it into this rotation. to print it than it did printing the way I originally asked for it to be printed, because of the printer actually has to skip void areas more. Not only that, but areas that are exactly flat and are unsupported tend to not print well, tend to sag and whatever like that. So I try to avoid unsupported objects with more than a 45-degree angle. Now, a light circle can do, because it starts off real thick. But as you can see, I set this back down there. It's going to take almost an hour shorter. I could even make it worse. All of these look so much alike. If I print it this way, now I've got this great big thing here overhanging that's going to fail because there's nothing underneath it. The plastic's just going to want to start going out this way, and it won't go out there. So, and as you can see, it will take still an extra hour to print in that orientation. So I'll just go back to the orientation I had it in, flop it down in there. And it's also possible to drop multiple items on the printer at the same time. Again, this is a very simple object that it's a switch cover. So there'll be an electric switch in there and little vents. This is a part for another 3D printer that we're assembling. Just thought I'd show, because I think most people think that the 3D printer is like an aspirin that cures all diseases. And in manufacturing, it's just one tool. We still need our old manufacturing plants. Most of the time when you make stuff, 3D printing is good for figuring out how to make stuff, making a few trials, or making the mold. But it's not really good at making part to part. Once you know what the part you want is, basically the machine's going. A lot of people are making fidget spinners. People are going out and buying 3D printers to make fidget spinners. These are little devices that have 3 bearings in them, and they rotate when you hit them. And I basically see those as giving your children carpal tunnel disease.
I always thought that 3D printing was just to make molds. That way you just ship it to some place. Like if you're going to make plastics, you ship it to Mexico or something, and they'll make the plastics from that mold really cheap, or metals somewhere else. But I think a lot of people, when the prices came down, they just pretty much used it to make like plastic figurines, like toy parts, just because
you can do. This device back here actually has 3D printed parts.
Can you not share the screen?
Oh. I got to figure out where the stop is. Okay. Now you can see me. This device behind me here has 3D printed parts. This part here has unusual contours that would be difficult to mold and get in there. So it has a hole going through it this way, one going through it here, one going down, and you can manufacture this. But this printer can actually make parts like this, and its counterparts on the other side. Some of the parts here, this part here is printed on this printer. So the printer can actually duplicate some of its own pieces to make another one of itself. And just a second. So this is actually a use for it. It's to make up the molds to do this would cost probably one mold like this, minimum cost would be probably $50,000. Where to just actually print this, since it's not a heavy weight bearing load, it's not, if this breaks, I might get a bad print, but it won't kill anybody. So it's not really a critical part. And that's the next thing is, the metal with made the standard ways has its strengths and the known material where, if there was a person's head underneath here, I wouldn't be using a 3D printed part that I didn't x-ray and make sure it didn't have any flaws in it or anything like that. Whereas if I'm making something for my own use and I know that I could switch over to another 3D printer and replace that part if it broke it, it's not as critical. So, it's okay to use there. If I wanted to, I could also get plastic called RTV, can pour it over this part and peel it off and then use that RTV to make a copy of what's in there. And it'll come out pretty close to this. And for the people that are making figurines, that's the common method they'll use, because they can get at least 50 figurines off of one mold. And some of those figurines, custom made, can go for $1,000.
Wow.
Val, figurines, make some.
I'll try.
So, who knows what kind of economy we're going to have in a year? Maybe we'll have to.
Yeah. Yeah. The economy, if it's about consuming and buying, it's going to be hard to.
I have some concerns about using them for children's toys as well. You want to make sure that that it's a good print, that small pieces aren't going to break off that can harm your children.
Yeah.
And again, when you're doing things in production and you make 10,000 of it, you've got no problem taking 50 of them and destroying them in all kinds of cruel ways that special engineers that are their whole career is how to destroy things, can test out and see if it's safe for children. When you're making a one-off, and a lot of times there are sites on the internet where you can go out and you can get models that somebody else has made and print them on your printer. But you don't know what they've thought of safety-wise or performance-wise. So, there's a caveat there. You get what you pay for. And if you take something for free and make it, you need to make sure that it's safe for your use and for your children's use. The different pieces, and again, this one here has a part that moves in what's called the X axis. These parts that go up and down. This is the Z axis, and back and forth is the Y axis. So the part rides on this and just goes back and forth. And that's all this part can do is go back and forth. And the plastic goes this way and that way. So by moving the two, you can position them relative to anything you want. And then for each of the layers, you just keep making it going higher and higher and higher. And the part builds underneath it. I should have been building a part during this.
Yeah, that would have been cool to see. So
maybe one of the nights, if it's not too loud, I'll turn it back on again.
Yeah. So when you zoomed it in by 1,000 times and you saw those strands, now if you make a mold, how would those strands affect the final product?
Well, there's ways to smooth it out. First of all, again, that was an initial print to see, what do I think about the size? What do I think about that device? What am I going to need to change to make it operational? And is it going to fit the client's needs? So the next print after that would not have been as sloppy. And I actually can go with smaller size strands than 200 microns.
Okay.
So can make it fill in. When you print at less than 100 microns, the prints take a very, very long time. Because you imagine if it takes an hour to do a layer, and it takes 10 hours to do a millimeter.
How much wattage does it take up to do a print?
It's less than 300 watts.
Okay.
Maybe 500 at most. And print times can be from 17 minutes to 5 days, depending on what you're making. Now, if you make almost 1 millimeter thick strands, you print much faster than if you're doing a very thin strand. And when you're printing a really thin strand, it doesn't even look like this is moving. And if you're printing, there is actually a thicker size than that. And there are people now that do a lot of prints, and they actually grind up their unused or their mistakes or extra material that they have and remelt it and make their own film. This is filament. Looks like a wire. It's plastic filament. They'll make it, but one of the problems you have is this filament loves to absorb moisture. So in the summertime, you have to dehumidify them. I'm really horrible about that. So I know that as I'm printing on this one, occasionally I hear it. And that's the sound, a little bit of moisture getting in there, which degrades your quality. So if I have a high quality print, I've got to do something like heat up some rice in the oven for a while. And then after the rice cools down, put it in a bag with that, and it'll suck all the moisture out. You don't really want to put stuff that melts in an oven. So, and then, I can't see if there's any questions.
I'm looking. Buffering, yeah. Something is wrong with my connection, I think.
I don't have a screen shared, right?
Nope. You don't. I'll see what I can turn off.
Having the microscope up as a second camera really throws me off a little bit. Oh.
Yeah.
I'm looking back through it if anybody sees any. Will anything goes happen tonight?
I guess I haven't heard from Dave. I'll see if Dave's going to do anything. So Snork, like I remember the 3D printing was starting to be a craze a couple of years ago. I'm not sure if, I haven't heard much about it, but like, is it a big like community? Do you see a lot of people sharing?
There are a lot of people sharing, but I see it as I don't think it has the same wave that it did a year ago. People wanting to get into it, everybody thinking that it was the answer for everything. Well, I think a lot of people did find out that it doesn't solve all their problems. And then after you've made a few trinkets, what's it there for? It's like a saw. If you don't have a need for a table saw, it doesn't do a lot just sitting in your living room.
Yeah. Do people sell a lot of their diagrams or whatever, their 3D models?
People do. Several places. There's exchanges for selling the models. some models can be very expensive. Some people will sell models for $10,000 to $15,000.
Wow.
A good model can be very, very expensive and take a long time to make.
Yeah. Now, don't you get into like how does not copyright? What's the term for it?
It's a gray area.
Property.
Yeah. How does that factor in?
Well, if you come up with something unique, you're talking patent law, or if you're talking about artwork, you're talking about copyright law.
Okay.
Since it has a very big gray line between whether it's, I guess you'd say how it's used is whether it's a copyright or a patent. And those are your only two protections.
Now here's the thing, because some patents might already be out there, but when you create the 3D model for it, that's using that same patent. You can't really patent the 3D
That's
model
correct.
version, right?
Unless you come up with some new feature that they couldn't do without 3D printing.
I see.
And some patents are well written that don't allow derivatives, and some can. And once you get to that point, we'd have to turn it over to a patent attorney.
So
that's not my area of expertise.
Yeah. So what if you created a 3D model that was already patented, but you thought that it was your original creation? So there's a little bit of differences because, of course, someone's model isn't going to be the same exact as yours, but all the features and concepts are pretty much.
Yeah, that's kind of to the legal system, but I tend to think it's toward the closer you get to being a duck, the court's going to call it a duck and give them the money.
I see.
Or they could tell you to cease using that design.
So it seems like people who've already started kind of have the leg up in like the legal
quite a bit
part. Okay. That doesn't mean you can't make it for yourself, right? You just can't make a product and sell it.
Well, with any type of patent infringement, it's up to the person that's being infringed on to call it. If they don't know it's being infringed on, then that's the issue.
Okay.
But ethically, there's a barrier there too. But we have a lot of ethically challenged people in this country.
Yeah.
Even some that aren't running for office.
Well, we all know that. We all knew that. I'm not sure if I should say it here since it's technology. So where do you see 3D printing going from here, say in the next 5 years?
I think it'll be taught in high schools.
Okay.
I think it'll be just probably either with the industrial education or the art class, or some schools might combine, industrial art with art class.
So no more wood shop class. It's going to be 3D modeling?
A lot of places already don't have it.
Oh.
A lot of small schools prioritize sports over music, industrial arts, and regular arts. And foreign languages.
Yeah. Yeah, that's a shame. I mean, I always thought would have been cool. I guess it's probably not a good idea is to have like electrical engineering or anything that has to deal with power. You don't want to fry kids up.
I think they should be learning electrical safety because they're going to be exposed to electrical devices at home. Sure. I think 12 years and older and above. I think I took household wiring when I was 12. And that was taught in junior high. And none of us got hurt much.
Yeah. Yeah, I wonder why it stopped.
We did a similar thing, but we constructed an entire house.
Mm-hmm.
Uh,
Well, we would,
you learn a lot from it.
yeah, we would do the wiring without the power being plugged in. The instructor would power up the unit.
That's normally how you wire something.
Yeah.
Yeah, if you're trying to do it the other way, I would suggest take a pause.
Yeah, but I mean it's I consider it pretty safe the way that we were taught, and I'd say electricity is much safer than woodshop. Of course, it was the same thing for us; it just all was mixed in.
As long as you're grounded, you're fine most of the time.
It depends on what exact live wires you're working on. If it's like in a house environment, you pretty much want everything turned off. If it's like you're replacing power lines, that's why those buckets have a rubber boot at that arm there.
Yep. That's what I said most of the time. The thing is, they didn't teach that at junior high or high school for me. I pretty much had to got involved when it was actually military school. So it's I think it'd be kind of nice. Yeah, we don't have a lot of electrical engineers these days. So,
well, we're not going to have any more until we start teaching them, starting when they're 10 years old.
Yeah.
No, really.
I know.
These exposures need to happen much younger.
Yeah.
Just think of it as any other skill. You learn how to throw a ball when you're 4 years old. We have people constantly. I mean, almost every school prioritizes being able to throw a ball over any other skill that children have.
Yeah. You got these pro golfers, pro tennis players. They're starting at 4 years old. And they're pro because they start so young. So it's the same concept.
Yeah, especially with electrical. I mean, there's constantly new things getting added and different ways of configuring things and different ways of it just there's more and more and more and more. And right when you think, oh, I'm good to go, there's still more. So and then there's every aspect of it, from electronics to large components and high voltage and things like that for power lines, or even high voltage for small electronics. I mean, the amount of information there is to go through to be like the top tier electrician is pretty. You need to know a lot of everything, pretty much, technology wise, electrical wise, math wise, even some of the history to know how this stuff was set up in the first place. I mean, a lot of information that goes into it.
Yeah, I've had to help people with wiring in their houses before. The first thing that goes through your head is, why did they do this? Especially out in Iowa, you'll find houses that are 150 years old.
Yeah, the old ones have a completely different wiring system.
Yeah, but they've been rewired and then added on and added on and added on.
So it's a big Frankenstein electrical grid monster, and you got to try to find your way through this big pile of wires.
I can remember awful. At my great-grandfather's house, he had a problem with an outlet, and I went to rewire the outlet. And once I got the outlet,
don't assume things are standard, right?
They use coat hangers. So when you're done with a coat hanger, you saved it. And when you needed a wire, you just took whatever it was. It wasn't copper. It was low-grade steel.
You got heating elements in your wall.
Yes. And
oh God. I mean, you can do some of this stuff and it'll work, but you're cobbling.
But that's the way a lot of houses are in the United States. And I'm certain that his wasn't the only one.
Oh God, no. It never is. When you see one, there's about 50 you didn't see.
Well, in an area like that, when you saw one farmer doing it, he's probably training the others.
Oh, how do you think they all learned how to do it?
Yeah.
Yeah.
So baling wire, coat hangers, you name it.
Anything available to them that they can use, any resource that's already been, when that's it. You got to really admit, it's like the fact that they did it really dangerously, and they did it with a small amount of information they were going on for everything. they were able to get functioning systems without always burning their house down. But I mean, it just shows you if you give these people enough resources and enough information about stuff, they can do some pretty impressive things.
Yeah, these wires had no insulation, so you'd see like pieces of wood jammed,
holders, spacers,
yeah,
keep it off of stuff. So
they jam a piece of wood into it to hold the two wires apart. So you know, if anything moved in the wall, like a mouse fell down across it.
You think that's bad? Have you on the high voltage for? I think they're 12 or what was there 12,000 or 14,000 or something like that run for the distance around here. Apparently one of the grounding wires were bad or something happened, but apparently a deer walked up and it deep fried the damn thing.
Yeah. Lightning struck a tree across from my house, and the tree just blew up. There was actually chunks of wood went through the roof of my neighbor's house. And
yeah, there's enough power there to make a decent sized explosion, surprisingly.
But the wire fell down on the street.
Stuff.
The wire fell down on a concrete street, and you know, you think of concrete as an insulator. It wasn't enough for what was there, and it arced to the ground through the cement, and it ended up burning a hole probably 3 feet in diameter, maybe 6 feet deep.
Yeah, it's like it's only an insulator to a point. You can say that for almost anything. Even your skin's an insulator to a point.
Mm-hmm.
Yeah.
So
I think there was something similar during it not burning a hole through, but an interesting. Have you ever heard of petrification? Are you familiar with that process? Mineralization of organic
material? from wood.
Yeah, but evidently in Canada, a power line went down, and it was evidently moist conditions, a lot of minerals in the soil, and some of the stuff was buried, and they found petrified chunks of wood or something. You know, I'm not sure if that's, I just thought that was an interesting thing. Like, that's one of those, along with burnt holes in roads, fried deers, petrified. You'd be surprised what high voltage can do to things just randomly occurring.
Yeah, I did see a power line fall on a power truck. The tires don't provide any insulation. Within 30 seconds, the tires are on fire and the truck is on its rims. Within 30 minutes, there's no more truck. It just burned the truck, the whole thing.
It's almost like an arc furnace at that point.
Yes. And that was with one of the higher voltage lines.
Probably upward past 200,000, probably.
The normal power lines, like going to your house out the street, if a power line goes down to the ground, 30-foot radius. If your feet are beside each other, you won't feel a shock. But if you have one foot in front of the other, you could get a very bad burn going up your leg and across. If you fall down after your legs get burned, you tend to get killed. So we were taught in some of my safety programs that if there's power touching your vehicle, do not step out of it, because people tend to die as they're stepping out of the vehicle. They say, get out and bunny hop your way out. If you don't think you can keep your balance bunny hopping, don't get out unless your car's on fire.
Yeah, because you don't want to create a differential, basically from a higher voltage to a lower voltage. You don't want to be in the middle of that.
Yeah, and it's just amazing how far away you should need to be from a piece of wire in the ground. So sorry if I got us off track there. Did you want to switch to a anything goes? I don't know how many people we have. I'm showing 7 people.
There's more than that.
I see 19.
There's 20. Dave hasn't responded, so Eric says he'll host Anything Goes.
Okay.
Snark, I'd like to ask you something related to that printer thing. I heard you mention clay, plastic. What else do you mention? I think you mentioned. Oh yeah, food.
And also buttercream.
Okay, but
really
the
fancy
metal
decorations
ones,
for cakes.
I was going to say, have you seen some of the metal ones? There are two types of them that I know of. One's an actual like wire welding sort of kind that's similar to the plastic printer, just with metal wires instead and welding.
Mm-hmm.
And then there's also the it's like compacted powder they put into a thing, and then they have I'm not sure if it's a laser or just
usually a laser.
Yeah,
you can do it with plasma as well. It's not as fine, but if you're doing a large print, plasma is fine. And you're basically just melting the metal at that one layer as it goes in. And it doesn't actually have to quite be melting. Usually it's when it's called sintered, it's taken up to about 90% or 80% of what melting point is. So it's up close to melting, but it's not quite there, and it still bonds, but it doesn't quite melt.
Go into a liquid form.
Yeah, you don't want it to be a liquid because then you can't control where it's at.
Yeah, it's more of a colder sort of welding.
Yeah, and things do stick right before it, and you'd be surprised how strong it is at that point. When you're doing it with clay, it's very close to the same process, but
I imagine the clay would be similar to the food one.
Right, but when you're doing it with clay, people have been doing clay for a long time, and they've got down how to sinter clay to the point where you get glass. You will notice that if you've taken something and fired it versus taking it actually from a liquid pool of glass, you get the little grains when you break it. When you break glass, it shatters conchoidally. It's always bending. You never have something flat in glass unless you use some kind of special technique. So that's the difference between the clay pottery.
So you could probably make some pretty good fan blades with 3D printer. Do you think?
Yeah, especially if you use more than one material.
Yeah, and then to make it spin, you could just create a coil. And
yeah.
I don't need to buy Noctua fans anymore. I could just buy
no. Noctua you need to buy.
Yeah, I know. And they're expensive.
If you could duplicate a Noctua in 3D, that would be something fantastic.
So people who don't know, Noctua is just a company that makes specialized, not even specialized, they just make really good fans for computers.
Fans.
Quiet, yep. So they're made in Germany, and of course German engineering is hard to top. But yeah, they're pricey. I think a 120 millimeter fan is around $18.99.
Wait, mute for a second.
Are you showing us a fan? Oh, never mind. Eric, while we're waiting. Oh yeah.
Oh, cool.
This is a Noctua fan, still in the box, getting ready to go.
Well, I've got maybe 60 Noctua fans around all my systems, but I'll let you know this: if a fan blade breaks on a Noctua fan, all you have to do is show them a picture. Yeah, people don't like the beige colors, but I like them. They'll send you one without having to send in the part. You just have to read off the serial number that's within the fan, and they'll tell you to destroy the fan. So they don't want you to like.
They have special features in them.
Yeah,
it's so small you can't see it in here, but there's little things in there. They figure out where the part of the fan is that has what's called cavitation, where it's air pressure is not as strong there, so that it flutters and it makes sound. So these fans, even though they're big, I've got another one that's tiny. They actually are extremely quiet.
Yeah.
And the fans you hear in the house right now are the one for keeping me from sweating, and another one back here to clean the air, which I should have shut off before we started. But,
wait, you're using Artua fans for that?
No.
Oh,
you wouldn't hear them if they're an Artua.
Yeah. Do you run them at the 12 volts or 7 volts or 5?
12.
12. I run mine at 7, and it actually you can't really. That's inaudible pretty much at 7. But it's still really quiet at 12 volts.
Yeah. If I were to shut my other, like I said, the household fans down, then it would go silent in here. You can't tell that my PC is on when I'm running it.
Yeah. I mean, I've tried other fans out there and just even made it so it's variable and, turn it down to around 7 to 5 volts. And yeah, they're still louder than an Artua at 12. So anyways, enough of that. People are probably wondering, what are you guys talking about computer fans for? All right.
Mm-hmm.
So we'll stop the stream and we'll continue on Eric's.
Thank you. Appreciate it.